Hi ladies, we're going to go through the first part of your matrices topic, so 5A, the basics of matrices, a lot of definitions basically to begin with, and if you're new to matrices, don't let it overwhelm you. It is not a very difficult topic. Just sometimes when there's definitions, the easiest way to overcome it or overcome learning them or remembering them is just to highlight them. So whenever you see something you need to remember, or I think you should remember, I'll highlight it for you. I can't write on PDFs, unfortunately, so let's see how we go with just highlighting. Okay, so basically a matrix is just an array of numbers. Okay, so we can use matrices to calculate large things, apply them to large problems basically. So if you're familiar with Excel, you can set up a lot of things behind the scene, I guess, using matrices. Basically, the way they work is each number represents something. So you can have like the sales in a week, or you can differentiate different things. So you might have chocolate cakes and vanilla cakes, and you want to know total sales for week 1, week 2, week 3, week 4, and how things will go in the long run. Okay, so they kind of simplify things, although I don't think I'm making things sound very simple. First of all, we deal with columns and rows. So you can see in this matrix here, the example is a store wishes to track how many tops and pants are sold over a weekend. Now, technically, we should have, instead of column 1, column 2, row 1, row 2, we should have tops and pants and the weekend, Saturday, Sunday. Okay, so in the above matrix, Saturday sales are given in row 1. Okay, so you can see here row 1 is Saturday and row 2 is Sunday. And then our column is tops, and then pants. Okay, so basically this number 6, and I might just highlight it so you can see what I'm talking about. Oops, maybe not. So the number 6, there's only one number 6. That's how many tops were sold on Saturday. Number 7, how many pants were sold on Saturday. The 8, how many tops were sold on Sunday. And 4, how many pants were sold on Sunday. Okay, so just interpreting a matrix. Your rows, sometimes, I mean, it sounds weird, but I always picture, if you go to the cinemas, you sit in rows. So you're going across. Columns, I think of it like this grand house being held up with these columns, huge columns out the front. Okay, so they're up, down. So if you get confused about rows and columns, you can remember it that way. All right, this first part, and I want to see if I can actually highlight this. This is important, the order, okay, because the order, even though we talk about, all right, 2 times 4 is the same as 4 times 2, in matrices, not the same thing, okay, so we always have to have it as the number of rows times the number of columns. So your rows come first and then your columns. Okay, so rows first, columns second. You need to remember that, because if you did it around the wrong way, did it around the other way, it is the wrong way. All right, the second thing is the position of an element within the matrix can be given by. So I'm going to highlight this as well. So the A, the dog's just in here breathing very heavily. The A just represents the matrix, okay? So it's basically matrix A, and matrices are represented with a capital letter. So this would be a matrix with the capital A, and then the elements within it have a lowercase letter. So this is lowercase a. Now the I and J just represent the row number, and J is your column number. So if we go back up to the previous example, 6 is element A, lowercase a. So see how our matrix is capital A. Lowercase a, 1, 1. It's in row 1, column 1. Number 7, the element is A, 1, 2. Row 1, column 2. The 8 is A, 2, 1. row 2, column 1, and 4 is a 2, 2. So row 2, column 2. Okay, so that's important to remember. I is your row number, J is your column number, and alphabetically, I comes before J. But I can't think of a way of remembering that. So just make sure it's highlighted. It's in your bound reference. You can always go to it if you're confused. All right, special types of matrices. Okay, we have row. As it says, it's just a row matrix. Okay, it's a single row. We don't have 2 rows, we don't have 3 rows, we just have 1 row. Okay, just one single row. You could have as many columns as you like. Okay, so that's what it means by the J. The J just represents the number of columns you have, but we can only have 1 row. And then obviously a column matrix is the opposite. So a column matrix is just a single column, but you can have as many rows as you like. Now the square matrix, okay, is the same number of rows as columns. So it looks like a square, okay? So we've got a 2 by 2, 3 by 3, 4 by 4, blah, blah, blah. That's a square matrix. Now, zero matrix, everything inside the matrix is a 0. Now, you might think, when would I actually use that? You will see them, okay? Probably not very often. Usually we use a binary matrix. So if you're familiar with computer coding, binary is number 1 or 0, and so it's a matrix with zeros and ones, basically. We'll get to that. Don't worry about writing that down just for now. All right, putting things into your calculator. So instructions are here, but how about I just give you a live calculator that hopefully will work. Okay, so this is the second CADS, but it looks well, doesn't look exactly, but it's very similar to what you have. Your matrix button is here. Now it looks very small, just next to your 9. When you press it, it will it'll come up with other things than just the matrix, but these are what you want. This is a 2 by 2 matrix, a 1 by 2, a 2 by 1, and this one here isn't a 3 by 3. You press on it and it'll ask you, well, how many rows and how many columns do you want? Now, the good thing is, if you get the order around the wrong way, so remember the order is how we write our rows and columns around the wrong way, it will, sorry. Let's go through that again. Okay, so I'm going to have 5. Now, if you did it around the wrong way, it shows you, okay? This is what a 5 by 3 matrix looks like. If you wanted a 3 by 5, then obviously you just delete it and then you do the right one, okay? So don't be worried. I've done that many times before. Just a quick tip. I was just using my arrows then, but tab is always easier when you're navigating between menus. Okay, and there it is. There's your 3 by 5 matrix. Now, entering in values, you press 1. I always find tab easier than your arrows. So tab will just go to the next number, and it's a lot quicker. Now, the thing is, every element in a matrix has to be filled in. Okay, so if you leave something blank, so you might say, oh, the next number is 0, I'm not going to write it. So I'll just quickly fill it in. Okay, so you might say, oh, this element here is 0, I'm not going to bother writing anything, go away. It's going to come up with an error. Okay, so if it's 0, you tell it it's 0. Okay, and there it is. Now you can store it. I don't know too many people who store it because sometimes if you do a lot of questions and you're not clearing memories, things get complicated. So you can say to your calculator though, all right, calculator, this is my matrix. I don't want to type it again. I want you to just call it matrix B. Okay, and it's done that for you. So if you wanted to do 2 times this matrix, which is scalar multiplication, which we'll do soon, see how it came up in bold? Now it's going to scalar multiplication basically is multiplying everything by whatever that multiply is. So it's 2. So you can see 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Okay, you can tell it to do, I'm just trying to think what else you could, that's what your calculator does. So we can actually ask it to, your calculator, your notes, you can actually ask for the element. So and I'm going to cheat here because I can't remember how to do it. Let me just go back here. All right, so you can actually ask it for a element. So here you can, well, vaguely see, it's asking for matrix B, what is element 2, 1? So if I just go back to my calculator, okay, we want square brackets. Oh, this is going to test my memory. Second, awesome. And you might want 2, 1. And sorry, you can't see that. There it is, the number 4. Okay, so if we go to row 2, row 2, 1, column 1, what? Hold on. All right, I know what I was doing wrong. I was reading it from this matrix here, which was 2B. We want to go back to B. So there it is, 4. Okay, so row 2, which is this row here. I don't know whether I can highlight it. This is row 2, column 1. So we're just now looking at this number here, 4. Okay, so there's your answer. Sorry, I was looking at this one. You will over time, there'll be a purpose for allocating it just a letter. But I think when you're just doing simple things, it's just easier to, let me just go back on my calculator, just scroll up and highlight it, press enter, and then do what you want to it. Okay, but you can allocate it a letter. The only problem is, let's say you were doing methods and then you wanted to do something like a solve that used the letter B, your calculator has stored that matrix as B. So you always need to start a new document. So new maths class, new document. Just remember that if you want to start storing stuff. But store is a good thing if you know what you're doing. Okay, so there's, I've got some examples. Okay, let's do that. Let's do these examples. So matrix D, here it is. Give the order of matrix D. Remember we do rows, then columns. So 3 rows, 4 columns. So the order is 3 times 4. We don't put it in brackets. You put it in brackets, it's wrong. It's just 4 times 3, no brackets. State the value of the following. So D24, so row 2, column 4. So row 2 is here. Column 4 is here. So it's 3. Next one, 1, 3. Sorry, oh gosh, oh no, I've just highlighted everything. Okay, so let's highlight that. So column 1, oh, I've just highlighted everything. Sorry, guys. 1, 3, so it says number 4. And then 3, 2, column 3, sorry, row 3, column 2 is 1. But if you wanted to, you can put that into your calculator and do what we did before. Just allocate it the letter D, and then D, square brackets, 2, 4, etc., etc. All right, question 2. Some students were asked which of the 3 musical instruments they preferred to play. All right, so we've got year 10, 11, and 12. Usually this would be written on this side. Sorry, I'm just pedantic about that. It's how they should be written. So this is matrix I. We've got year levels and we've got musical instruments. So how many year 11s preferred piano? So we'll go to year 11s, piano, 2. Give the order of matrix I. It is a 3 by 3, 3 rows, 3 columns. What information is given to us by I3, 3? So you can see lowercase I because it's a capital I for the matrix. The letter doesn't really matter. Okay, you'll see all different letters used. This is probably I because we're dealing with instruments. Okay, so 3, 3 is this 12 here. So that 12 represents the number of students in year 12 who play violin. Okay, so 5A, questions 1 to 8. Good stuff, guys. Bye.